Welcome back to .NET Rocks. This is Carl Franklin.
And this is Richard Campbell.
We're in Prague.
We are in Prague. It's nice here.
This is my first time to the city. Yeah. I went out last night. Richard Morris is also here.
Oh, yes. You got both Richards. How confusing.
Yeah, my worlds kind of collided. My heads are exploding. My two Richard podcast co-hosts. Anyway, we were walking around last night in Prague. We went downtown to have some meat, as you do.
As you do.
And it was just beautiful. So I'm looking forward to Saturday. We're going on a little tour. But we're here at the Update.NET conference. And this is the first time they've had this conference here.
Yep, brand new.
And what a success. They
Yeah,
were shooting for like 300 people. They got 450.
Something like that, yeah. It's a big room. My room was full. People were pretty excited.
Yeah, people are very excited.
Talk about an evolving community, right? You're growing to a place now where they can host their own event annually at least.
Right.
And help grow this community even larger.
Yep. It's awesome. All right. Well, Adam Sitnik is here. We're going to be talking to him in just a minute. But first, let's do the thing we call Better Know a Framework.
Awesome. All right, man. What do you know?
What do I know? Well, I know about this app/hardware solution that I'm going to talk about right now. It's called Fixed, F-I-X-D. And believe it or not, I first heard about it on Car Talk. Now, I know Car Talk is off the air.
Yeah.
But, and Tom Moyazzi died.
He's actually passed away, yeah.
Yeah, but Ray is still alive, and he still does ads for the reruns for the podcast, even though it's off the air.
Because they're still being listened to, and so he's got new ads being inserted.
Exactly,
That's pretty amazing to think about that.
It's pretty cool, yeah.
And I don't know that everybody knows it listens, but this show is modeled after Car Talk.
Well, so we don't laugh quite as much as they do.
They're pretty goofy, but I've never held back of being goofy after listening to those guys.
No, it's true. And they have laughed so hard, they've had to stop, they're crying.
Yeah,
they're laughing so hard.
I've had that experience, just not on this show.
On that other show.
On that other show.
Anyway, so Fixed, F-I-X-D, is a hardware an app solution that you plug the hardware thing. It's a little Bluetooth thing that plugs into the data port of your car.
The OBD port, yeah.
Yeah, so everybody who has a modern car, essentially since the 90s or something, has one of these ports. And when you go to the garage to get your car looked at, the first thing they do is plug a computer into this port and download all sorts of stuff from your car's computer.
Right.
Which includes, maintenance, timeline, the vehicle history, mileage, and also all sorts of diagnostic things that the car computer has recorded along the way. So they don't really have to tinker around mechanically with your car to diagnose any problems.
Depends. I mean, there's some classes of problems that show up in OBD.
You're absolutely right. You're absolutely right. There are some. But here's the cool thing. You can just plug this in and know before you bring your car to the garage what that check engine light actually means.
Yeah, no, that's really useful.
Yeah, and so you're less apt to have somebody pull the wool over your eyes.
Yeah,
well, not that they do, but you
never know.
You never know.
At least you have a sense of what's going on. You have you're a little bit more involved.
Yeah. So it's getfixed, getfixd.io. Or, of course, this is show 1611, so you can go to 1611.pwop.me to learn more about it.
Awesome.
Yeah. Who's talking to us today, Richard?
Grabbed a comment off for show 1559, recorded back in July of 2018. And this is the show with Dustin Metzgar called .NET Core in Action. So I know we're going to talk a little .NET Core. Had a lot of fun conversations with him, actually. And this is a comment from Jimmy Hedden, who said, "Excellent, strangely funny show, guys." Why is that strange? That's not that strange. Whilst, okay, Jimmy, you used the word whilst, and you called us strange.
You get extra points for that, Jimmy.
Whilst I agree that the current pace of .NET Core is extremely fast, which will impact countless books and blog posts attempting to tame it, I, for one, love that Microsoft has been iterating at what must be an unprecedented cadence for .NET releases. Which, is true. They're going remarkably fast, but I feel like Windows certainly, but Studio 2 at the cadence they're releasing right now is struggling.
Yep,
they're having quality problems.
Yes, they are.
Folks are getting frustrated with it, and they're suggesting that this should slow down. I don't know if that's actually the answer. I think
I don't know.
Don't ship broken bits would be the better answer.
Something occurs to me that, they're putting more resources into code right now, Visual Studio Code maybe, but they're two different teams. So I don't understand why the problems.
I think you're dealing with a team. Well, Studio still has like 98 bits in it. So let's be empathetic about they are working on a very old 20 plus year old code base in some respects, and that they continue to modify. And that it's a challenge to build good enough tests around it to iterate as quickly as they are. But I would be keener in fewer new features and more stability.
Agree.
And I hope they keep going that route. And so that's, as exciting as it is to see us shipping out a band and new stuff coming all the time, as long as the quality's there, I think that's important. But Jimmy goes on to ask me, Richard, any chance of we publishing work in progress chapters for the book on GitHub? You previously interviewed someone who mentioned this approach worked wonders for them, and I don't remember what his name is, and the collaborative environment would surely make a good sounding board if you're looking to try a couple of different approaches. I am not thinking of that right now for this book, but I've also come to appreciate that I have amassed enough research that it might be more than one book. Not that I want to do an anthology of like the history of .NET, but that the book that I want to write first is much more the political history of .NET, how .NET moved through Microsoft and interacted with the community, as opposed to any given stack.
Right.
.NET is a lot of things to a lot of different people. I talk to folks whose whole relationship with .NET has been web development, or has been desktop development, or has been mobile development. And I almost think those are separate stories. For a while there, I played with, could I do each one? Or maybe, could I do a build your own adventure? Tell me what topics you care about and I'll generate you a book. But I've really gone back to, I'm going to write this core book first, sort of fundamentals of the history of .NET, and then explore, could we do a book solely focused on the history of web development at Microsoft? So I wouldn't just do .NET even, but the active server pages. And that, I think, might make a really interesting collaborative book more than this overarching piece that I'm doing.
And also starting with the history of the internet, because there was a lot of web stuff going on in the Unix world before Microsoft got even on board. And they had to learn some hard lessons, I think.
I've now done a talk on the history of web development just because apparently I'm turning into a historian. And it's been very interesting to talk to the different audiences about exactly that. What they learned and what they didn't. Jimmy wraps up by saying, keep up the great work. This episode, 1559, represents my passage into the 100% of episodes listened to club.
Wow.
That's a lot of episodes. So congratulations, Jimmy. And thanks so much for your comment. A copy of Music to Code By is on its way to you. And if you'd like a copy of Music to Code By, write a comment on the website at .NETRocks.com or on Facebook. We publish every show there as well. And if you comment there and we read it on the show, we'll send you a copy of Music to Code By.
And definitely follow us on Twitter. I'm at Carl Franklin. He's at Rich Campbell. Send us a tweet. We'll diagnose your problems for free.
But first, we're going to have to stick a USB into you.
Oh, and by the way, Music to Code By is now up to 18 tracks.
Congratulations, friend.
And you can get all 18 of those tracks in one downloadable MP3 bundle for only $42, because that's the answer to everything.
Yes, it's a good name.
All right, and let us introduce our guest, Adam Sitnik. Adam Sitnik is a software engineer at Microsoft focused on .NET performance and reliability. He contributes to a few open source projects, Benchmark.net, Core CLR, Core FX Lab, and the awesome .NET Performance List. Adam has spent much of his professional life working on systems for energy producers and distributors, including projects such as energy trading, production optimization, balance settlement, and critical events detection. So far, no blackouts.
Awesome.
Adam is also an ex-MMA practitioner, AFOL rabbit owner, and a huge Star Wars fan.
MMA is mixed martial arts?
Yes.
You are kind of a beefy guy. I think you probably mess us both up.
I wouldn't want to mispronounce your name, by the way.
Yeah, nobody would do that.
No, who would do that? Idea. Yeah. Well, and I didn't know anybody who owned any Volkswagen rabbits after 1990, whatever. I'm just kidding. You own real rabbits, right?
Yes, recently I have adopted second rabbit, so now we have two of them, and they're really lovely.
Are they pets or food?
Yeah.
Pets, of course.
Okay. So the question is now, will you soon have many rabbits?
No, because the main requirement for adopting a rabbit is to make sure that it cannot have more rabbits.
Yeah, that's
okay.
right.
So there are rules around all
I
of
learned that when I was 10. My father got rabbits for me and built a hutch where they could go around. And one day we discovered a lot of dead baby rabbits.
Yeah.
Apparently, not only do they reproduce quickly, but the male rabbits will kill the babies.
Yes, they will. Yeah. Rodents aren't always friendly and fun.
No.
You see that in hamsters and gerbils and
yeah.
Anyway,
let's talk about real stuff here. We're talking about spanification. What does that mean?
It means to take advantage of span and make your application even faster.
Span of T?
Yes, span of T. The new span, which got shipped in System.Memory package and requires C# 7.2 to get it working. The concept behind span is quite simple. It allows us to work with any kind of memory because it's just a pointer and a length inside. So we can create span for unmanaged memory, managed memory, stack allocated memory.
And so I thought we didn't have to deal with pointers in .NET anymore. So it's not really a pointer to an absolute memory location, right?
So it's an abstraction. So from the end user perspective, you could think of it like of a new array that can point to any kind of memory.
I see.
And when you create it from a stack alloc, you don't even have to use unsafe. You can do span of byte equals stack alloc.
Okay.
And provide the number of bytes that you want to allocate.
And so the big benefit is performance?
Yes. And when you think of it, when it's internally a pointer and a length, which represents any kind of memory, and you want to take just a slice of some part of it, like for example you do when you want to do a substring, then instead of allocating any new memory and copying it, we just move the pointer.
So, yeah.
So slicing is immediate.
So one of the benefits of unmanaged memory in C++, for example, is that you can just sort of look at a chunk of memory as any kind of type, right? You know, you can say, oh, this is a bunch of data. I can turn it in, read it as a bunch of ints. I can read it as bytes. I can read it as a string. You're sort of placing a type over it, if you will. What's the benefit? I mean, besides performance, is there any that kind of morphism?
Yes. So if you would like to turn a span of one value type to a span of different value type, there is a memory marshal type with a cast method, which allows you to do exactly that.
Great.
So I remember when I was searching many years ago for a question on Stack Overflow, how do I turn an array of floats to an array of bytes, because I wanted to write it into a stream. Right. Now it's just a single call, and the action is also immediate because it's just a cast.
So with managed memory structures, you can use the convert, like 2-byte, convert to int32 when you have something that's of a different type. A long to an int32, for example, int64 to int32. And that kind of thing does. And then there's also bit converter, which does arrays, I believe, if my coffee brain is working this morning. But what you're saying is that there are a lot of extra steps in copying memory that go on with those things. This way you're just essentially moving the pointer. It's really, really fast.
Yes, exactly.
Yeah.
Those methods do calculate something. And here with memory marshal, we don't change anything. We just change the type.
Wow.
To represent. And we also calculate new length because, for example, a span of single float is length of 1. And if we turn it into a span of bytes, it's going to be 4 bytes.
Yeah.
When you say unmanaged memory buffers, are we literally talking outside of garbage collection and regular .NET operating space?
Yes. So most of the .NET developers are familiar with new operator, which allocates memory on the managed heap. But we also do have the possibility to use unmanaged heap and stack allocated memory.
Okay.
To allocate memory on the unmanaged heap, you need to use Marshall API. But you can store their only values. You cannot store managed pointer on the unmanaged heap. Moreover, if you think of it like of an unmanaged memory, you need to remember that you are responsible for freeing it.
Right.
Because it's unmanaged. And also the order of allocation matters because for the managed memory, GC can compact the memory for you.
Right.
With the unmanaged memory, the order which you allocate and free memory can affect the fragmentation.
Well, you're going to have fragmentation because if it's unmanaged memory chunk and you're laying it in the same spaces where the GC is going to work, it's just not going to touch it. It's going to work around it.
But the GC won't work in the unmanaged space, right?
So this is why it's called unmanaged. Like it's not managed by a GC. So it's the same process, but the GC is not aware of this part of memory.
Okay, so you're writing into a different location then.
Yes.
It's not part of the heap.
Yes.
Okay, well, I think it's an important distinction.
The advantage is that you don't create any pressure for the GC because it doesn't have to manage this memory.
Right.
It doesn't have to clean it up, compact, whatever. So people typically put their huge chunks of bytes or integers, something that they want to hide from garbage collector.
Right. And so I would think big chunks of memory is what we're talking about.
Like, for example, you could implement an unmanaged memory pool and just take small chunks of it using span.
Sure. Is there any chance that since it's unmanaged that things could get overwritten by other code?
So it's up to you as a software engineer. Of course, it's possible.
What? Responsible behavior by developers? What's that about?
But if you would like to have a memory which is always safe, you can use, when it comes to concurrency, of course, use stack allocated memory. Because stack allocated memory can be accessed only by a single thread at the same time.
Right.
Cool.
So the unmanaged heap is still in the process. So your app that's running is the only app that's going to talk to that memory, correct?
Yes.
All right. So when you say you have to be careful, you don't actually tell it where to create memory. But when you allocate memory, can you be sure if I allocate a span of memory from one section in my app and I allocate another span of memory later, you can be sure that those two spans won't overlap each other? Or is there a possibility that when you write over the first span, if you go beyond the length of it, you could run into some other
So span ensures type and memory safety. And when you are creating it out of unmanaged memory, you have to provide the length. Okay. And it doesn't allow you to get behind the length. So
it doesn't allow you to increase the length.
Yes.
That's it.
You can only just slice it.
That's the key. So that's the reason why you can use this without fear of writing over.
Yes.
Yeah.
That's smart.
That's very great. I mean, you're basically getting the best aspects of managed memory, which is safety.
Yep.
You know that nothing else is going to touch this. And speed. Wow. That's great. What are the downsides?
So when it comes to stack allocated memory, do you know what happens when you try to allocate 2 megabytes of stack allocated memory in Windows?
2 megabytes of stack allocated memory. So like if I'm in a method and I try to create a 2 megabyte array, what happens?
Stack overflow exception. Because
Boom!
On Windows, we have this limitation that the stack can be up to 1 megabyte. On Linux, it's different per distro. For the primal thread, it's typically 8 megabytes. For the background threads, it's typically 2 megabytes.
Oh, okay, let's make a distinction. That's not the actual space of the memory. That's the number of items on the stack?
That's the maximum size of the stack. So, and on the stack, we put your local variables of the method and also the stack allocated memory.
So if I try to load a JPEG file, let's say that's 4 megabytes into a string, boom, I've done that before.
Yeah, but not to a stack allocated memory.
Right.
So you need to be very careful when you're using the stack alloc keyword because this is allocating memory on the stack.
So if I'm in a method and I create a variable, isn't that on the stack?
If it's a value type, it's on the stack.
Oh, if it's a value type.
Yes.
Okay. And if it's a reference type, the memory is actually in the managed heap.
Yes. However,
but the reference is on the stack.
Yes, exactly.
Yeah.
However, 2 weeks ago, a new pull request to core CLR was merged, which allows runtime to choose if it would like to allocate reference types on the stack.
Ooh.
However, as of today, this behavior is still disabled. But we will have to update all of our slides, books, and everything.
If it goes ahead. I'm going to interrupt you for just a moment here, Adam, for this very important message.
This episode of .NET Rocks is brought to you by Datadog, a monitoring and analytics platform combining infrastructure monitoring, application performance monitoring, and log management into a one-stop shop. Datadog helps leading companies migrate to the cloud, transform to a microservices architecture, and transition from .NET to .NET Core. Their distributed tracing and APM provide end-to-end visibility into requests wherever they go, across hosts, containers, and service boundaries. See for yourself. Start a 14-day free trial, and Datadog will send you a free t-shirt. Visit dd.netrocks.com to get started.
And we're back. It's Richard Campbell and Carl Franklin here at Prague, or in Prague, at the Update Conference. And we're here with Adam Sitnik, and we're talking a little bit about .NET Core 2.1, C# 7.2, and the memory SDK that gives us these new, potentially dangerous capabilities. But as soon as you mentioned that sort of 1 meg limit, like that's OS stuff we're talking about. I think that for .NET people, we've been isolated from the OS for a long time.
Yes. And our target audience are people who create libraries. So other people could just consume it.
Right.
So we hope that the library authors are going to get the best of SPAN, and other developers will be just relying on that.
That makes a lot of sense.
Yeah, and of course it plays really well into .NET Core, doesn't it?
Yes.
I mean, .NET Core is all about performance.
Yes. We want to have really, really fast web platform that allows for great cloud scenarios.
Yeah. No,
we don't want to have any overhead from the framework. So this is why we give you things like SPAN.
What's your role here? You live in Poland?
Yes, I live in Poland and I work remotely for the .NET team.
Okay.
I'm currently a performance champion. My job is to take care of the performance culture, to take care of the performance tools like Benchmark.net or Purview.
Right.
I also do a lot of performance investigations. Like, for example, currently I'm looking into the performance of ML.NET. I'm trying to identify some potential bottlenecks and places where .NET Framework could do a better job. So if I could ask my manager to, for example, investigate if it's worth to create a new type, something like SPAN, or maybe the thing that I have implemented last week called UTF-8 parallel file parser.
Right.
Parallel file parser?
Yeah. So in ML.NET, we parse really huge files, like gigabytes of data. And I have realized that with the things that we have as of today, it's really hard to take advantage of all your CPUs.
Yeah, no, it is. And the diminishing value of your CPUs as well. Like it's hard. You always have one core pinned. It's a question of what other core, what your other cores are up to.
Yeah. And just to give you an example, I was able to cut the time it takes to parse a real ML file from 2.5 minutes to 40 seconds.
Nice. And that was just parallelizing properly and utilizing multiple cores?
Yes, and utilizing SPAN.
Utilizing SPAN. So
yes.
That was, do you see that the benefit was memory efficiency or CPU utilization?
Both.
Okay.
And whenever you try to improve the code, you should first of all focus on getting the best out of the single-threaded. So once you squeeze the single-thread CPU performance, then you can parallelize it.
Right.
So the first thing I did, I have used SPAN and a new type called UTF-8 parser, which allows us to work with spans of bytes, which are just representing UTF-8 strings. And by doing that, I was able to cut like 40 seconds.
Nice.
Wow.
And then I just parallelize it.
And then parallel, because parallelization has an overhead too. You are breaking across the work, you are making calls across cores.
Yes. And this is why it's really important to not do it, for example, for small files. Because it would just take longer.
It's not worth the overhead.
Yes.
Do you, and again, I'm throwing hardware terms in here. Is there a visibility for us working with SPAN in terms of the memory, the NUMA memory availability across processors, or do we not have to think about that?
You don't have to think about it.
Okay, so memory is just memory. Don't worry about what the CPUs need to do to get at it.
Yes, exactly.
Okay.
Is there a way that you can, when you create a SPAN, tell it whether you want it to be in managed, unmanaged, or stack?
Yes. So SPAN has a few constructors. One of them accepts managed array. The other one accepts a pointer and the length. So it's up to you what you are going to try to create. However, when you are providing a pointer and the length, we are making sure that the type which you are going to create SPAN for, like bytes or whatever, does not contain any managed references.
I see.
So SPAN assures memory and type safety.
So it's interesting that they allow stack allocated memory structures. You know, why would you use a SPAN on the stack rather than just a managed performance, I guess?
Yes, and safe lifetime. And also, when the method ends, the stack is being unwinded and everything allocated on the stack is gone. So the allocation is immediate. And stack allocated memory doesn't have a lot of use cases. Typically, you allocate very small chunks of stack allocated memory. Something like 200 bytes, 1 kilobyte.
Sure.
Mm-hmm.
Just to, for example, parse a line or format a string. And it's also important to remember that stack overflow cannot be cached because there is not enough of space on the stack to execute catch block.
Right.
And this exception is killing entire process.
It cannot be cached?
It cannot be cached.
Can't be caught. Not cached, but caught.
Okay,
Yeah.
I'm sorry.
Sorry.
I'm getting, as opposed to cache. No, it's really important. It's like, you're not going to recover from this. The OS is going to kill you.
Right.
Yes.
It's welcome back to the old days where your app went away.
Yes, and this is why our official recommendations are to be very careful when using stack allocated memory. Moreover, C# 7.2 does some extra safety checks. So it's going to prevent you from doing some things that you shouldn't be doing. But you need to remember that the size of allocated stack memory shouldn't be, for example, dependent on the input from the user.
Yeah, this is not this is sanitize your inputs. Know what's coming in.
Yes.
You're going to explode.
It could have been a vector attack. Like somebody could have created a web request that will
kill your service. Yeah. It'll work just fine too. All you got to do is fire you 1.5 meg and you're done.
Yeah. This is why if you go to CoreFX or Core CLR and you search for stack alloc, you will see that every pull request which is using this keyword goes through detailed security review.
Right.
We have security champions in Microsoft, and they make sure that we are not accepting anything that could be dangerous.
This is literally a buffer overflow exploit opportunity. I'm just delighted we're talking about Stack Overflow and it's not the website.
That's true. Yeah. Plus, it's been a long time since we talked about, real computer science, anything.
Yeah. We don't have to. We've had so many years of not thinking about memory management.
I know, yeah.
I think
Chris Sells might have been the last person to talk.
The 32-bit to 64-bit versions of the OS and how we did memory allocation around ASP.NET and things, I think, is a little more recent. But even that's years ago.
Yeah, right.
We don't even think about it. Do you see any reason to run a 32-bit mode for any of this stuff anymore? Or is it just 64 all the time now?
Personally, I go 64.
Yeah.
However, there are some other scenarios like IoT and some more constraints.
Sure, where we're dealing with hardware that is still 32-bit.
We don't need all the memory. We need speed and performance.
Or when you have to develop a software that you just have to use some dependency that is built just for 32 bits.
Sure. Yeah. Well, that used to be the biggest issue for me was often the drivers we were depending on were they had 64-bit ones. They just didn't work. Or they weren't signed properly. They're just unreliable.
And if they didn't work, they weren't thunking hard enough.
So this is part of .NET Core 2.1 and C# 7.2. How do you get those bits?
So there is System.Memory package.
Right.
And this package doesn't support only .NET Core. It targets 16 target frameworks.
Oh my goodness.
Including .NET Standard 1.0, Mono, Xamarin, Unity, and few other things.
So I could be directly writing to memory in a phone? That couldn't cause any problems at all.
Wow. What was your involvement in SPAN? The development of it.
It's actually a very special type to me because it was my first open source contribution back in 2015.
No kidding.
Were you working for Microsoft then?
No.
I
have read a blog post from Aaron Stannard complaining about the state of .NET open source community. And Aaron explained what he did in his small startup to develop a single app in .NET. And he had to port Akka from Java to .NET, implement few algorithms, and at the end of the blog post, Aaron asked what other .NET developers are doing. Are they just writing Hello World? And at this moment of time, I was like, no, hell no. I'm writing software for, preventing blackouts. So it's a serious thing. And 2 days later, Joe Duffy has posted a message on Twitter that he have created a new project called Slice. It was called Slice back then.
Okay.
Yeah. And one of my favorite ways of learning is to read somebody else's code.
Yeah.
And Joe is one of my gurus. So I just immediately cloned the repo and started reading the code. And I found few places that could have been improved from the performance perspective.
Yeah.
And I did create my first pull request.
Wow.
Oh, yeah. There's Joe's Slice.net is still on GitHub. I'll include a link to it. That's great.
And that became SPAN?
Yes.
Wow.
That's so easy.
The story doesn't end here, because later on it was moved to CoreFX Lab. And CoreFX Lab is experimental lab for CoreFX, which is the basic class library of .NET.
Mm-hmm.
So we put things that are promising there, and if they are tested, and we believe that they should be part of .NET Framework, we move them to CoreFX.
Okay.
And a few years ago, when CoreFX Lab when the span was moved to CoreFX Lab, I wanted to improve its performance. However, my favorite benchmarking tool didn't work, benchmark.net, because CoreFX Lab was targeting .NET Core.
Ah, right.
And at this moment of time, I had no idea what .NET Core was. But I was really angry that my favorite benchmarking tool doesn't work. So I was like, okay, so I'm going to port benchmark.net to .NET Core. Yeah. It took me 5 weeks. And after I was done, a week later, the DNX was depreciated, and I had to do it one more time.
Oh, man.
Yeah.
You got really good at that.
Yes. And so this is how I got involved into benchmark.net. Only because I wanted to make the benchmarks for span working for .NET Core.
That's how all this came down. When did you join Microsoft?
In January this year.
Oh, okay. So most of this work was done as your side gig for fun.
Yes.
And then do you feel like that was part of your resume, that did they recruit you, or did you choose to join Microsoft?
I think it was mutual.
Yeah.
However, to get the possibility to work remotely, I think this was really important.
Yeah, key part. Well, and obviously you're capable of making contributions remotely. You had been anyway. The problem, of course, is that Aaron is creating a situation where it's self-fulfilling. As soon as you find a third-party contributor that's really great at adding to the core FX model, they hire them.
I'm not sure if it's the case for everybody.
No.
And one of the rules that I have learned at Microsoft is you need to ask. Yeah. And the story of me getting hired was, I was here a year and a half ago, and I met Karel Zygmunt at .NET Meetup. Mm-hmm. So I was giving a talk here. And we went for a chat. We had very nice conversation. And when we were coming back to the hotel, we have met our friend, Elizabeth, who is a recruiter at Microsoft. Mm-hmm. And Elizabeth said something like, hey, did you talk about work? And Karel was like, do you want to work for us? I said, of course.
Nah.
But I know that you don't allow for remote work. And Karel said, yep, for some exceptional people we do.
Yeah.
So this is how it got started.
Wow.
Do you get regular trips to Redmond out of it, though?
Yes.
Yeah.
I'm flying to Redmond next week.
It's a long way.
Yes, it is.
Yeah, but part of the job.
Can we talk about some of the new types that are in here, like UTF-8 parser?
Yes. So we need to understand that string in .NET is UTF-16. Mm-hmm. So anytime you read something which is UTF-8 and you turn it into a string, you allocate memory, copy, and so it's an overhead.
And the internet seems to thrive on UTF-8.
Yes.
Yeah.
So for .NET Core 2.1, we have released UTF-8 parser and UTF-8 formatter, which allows you to work with span of bytes and treat it as an UTF-8 string.
Okay.
So we allow for very fast parsing and formatting. And moreover, in .NET Core 3.0, we are going to ship UTF-8 string.
So this kind of, in the managed world, would be under system.text.utf8, all of those things, right? Where you're converting byte arrays and things like that.
Yes.
Yeah. All right. Good. Well, yeah, we need that kind of stuff. And the formatter, the UTF-8 formatter, is the way that you do it. What's the difference between the parser and the formatter?
So the parsing is parsing values out of UTF-8 string, and the formatter is formatting the values that you provide into a UTF-8 string.
Oh, I see. It's just the direction.
Yes.
Okay. Well, that's easy to know. What's a array pool?
Array pool is a pool of managed arrays. Because if you want to get rid of allocations, you can either go and use unmanaged memory or pull the managed memory. And when it comes to unmanaged memory, it of course has a lot of disadvantages, like the issues with safety. You need to remember about releasing it. However, you can also just pull managed memory and reuse it. So we have shipped a new type called array pool, which allows you to just rent and return byte arrays. One important thing is that array pool has a shared property, which has the instance of default pool. You can also create your own pool. However, I really encourage people to not do that, because the purpose is to have as few huge arrays allocated as possible. Mm-hmm. So if you start creating your own pools just to pool memory, then you end up with even more memory that you would just have when you would allocate single array.
Yeah.
So the API is extremely simple. Array pool.shared, you got the pool, and then pool.rent, you get it, and pool.return, and you return it.
Okay. So it's just in the duration of that method lets you pass the buffer back.
Yeah.
I like the concept of renting memory, because haven't we always only ever rented memory, really? The OS always gets to take it back whenever it wants to.
So to a guy like you, it's pretty obvious when you would use a span in unmanaged memory, but it might not be so obvious to the listener. Can you provide a few scenarios and when you would use these different areas of memory with the span?
Mm-hmm. So first of all, I believe that the managed memory should be always the default choice.
Okay.
When it comes to unmanaged heap memory, if you get into troubles with large object heap, like you allocate a lot of huge managed arrays, which contain only value types, then you could consider using unmanaged heap. When it comes to stack allocated memory, only small chunks of memory.
Yeah.
Up to kilobyte. And never in a recursive method, and never depending on the user input.
Right.
And if you would like to find more usages, everything we do now in Microsoft is open source in .NET. So you could go to ASP.NET repositories like Kestrel and search for Stackalog or Marshall and find the way ASP.NET is using it.
Yeah. So if you have like a set of dynamic things, like an array of strings, let's say, that's probably something that you wouldn't want to put in the unmanaged heap, right? Because the length of those things are going to change all the time, and the amount of memory they're going to use. But if you have something that's static, like let's say, a list of countries, for example, this is the classic list of static data that's never going to change. List of countries and country codes, something you want to look up really quickly that isn't going to change. Yeah,
but you need to remember that you cannot put managed pointers to the unmanaged heap, because DC works in the way that when it cleans up the memory in the generations, it might decide to compact the memory. And when it's compacting the memory, it's updating the pointers. However, if you would put a reference type to unmanaged heap, it has no idea about its existence. So it wouldn't update this pointer.
I see.
This is why when you try to create span out of unmanaged memory, we check if the generic type have pointers. If it has, you are going to get an exception.
Okay. That's why you said value types only.
Yes. So for example, when you are reading a file and you are using streamreader.read method and you are reading this bytes into a buffer, this is where you could use unmanaged memory. Because they're just bytes, they're just values.
And you know how big any given read is going to be, so you're not worried there.
Yes, but when it comes to the read method, you have to specify the length.
Right.
So you're just reading chunks. So you would have to
K at a time, or whatever chunk makes you happy.
Yeah.
Interesting.
Fast.
I'm thinking I'm going to talk to Mark Heath about NAudio.
Oh, I see.
Because he uses, audio buffers with ASIO, but they're managed buffers.
Well, and this is particularly what you were saying, is like, folks that are building libraries for other developers to consume can get these performance benefits and memory utilization benefits in their library. So that's exactly the same.
And actually, he's using unsafe mode in some of those things. But what's the difference between using unsafe mode to do pointers in the managed heap versus spans in the unmanaged heap?
Span gives you type and memory safety because it has all of the safety checks for you.
Okay.
So you don't need to go unsafe.
I see.
And
but performance is on par.
Yes.
Okay.
Exactly. And sometimes it's even faster. And moreover, when you're using unsafe in C#, you need to remember that CLR has the feature called IL verification.
Yeah.
So to ensure safety, it's validating the IL that you produce. So for example, to prevent from accessing an element in an array that belongs to a different array.
Yeah.
But when you go unsafe, we don't do that. We cannot do that because you're using pointers and we cannot validate this code.
Yeah.
And some of the cloud providers can, for example, put a requirement on you. Like you could run your .NET code, but only the one that can pass IL verification.
Okay. Wow.
And with Span and all of the features from C# 7.2 and C# 7.3, you don't really need to go unsafe anymore.
Is there anything else that we need to know about Span that we haven't talked about?
And maybe one more thing. Whenever you are not sure what to choose in terms of performance, you should profile it. And if your friend, as you said, is using audio streams and he's using currently managed memory, he should have right benchmark against pool managed memory and against unmanaged memory.
Okay. Sure.
So we should always measure. We should never be guessing. And surprisingly, unmanaged memory isn't always the fastest, and we need to measure that.
Yeah.
Sure. You just got to benchmark it and figure out if it's actually going to make a difference or not.
Makes sense.
Yes.
Because you're also making riskier code. Like you have to be a lot more careful when you're playing with unmanaged memory.
Yes, exactly.
So if it's not going to give you a big benefit, it's just not worth the risk for future maintainability.
Yes. This is why it's not our default recommendation.
Sure.
It's a possibility if you know what you are doing and you know every advantages and disadvantages and you accept the risk.
Well, it's like managing your own threads. Same thing. Most of the time you're going to do it wrong.
Yeah.
You know, it's like 4 people who know how to do it right and you're not one of them.
Yeah. Yeah. So what's next for you, Adam? What's in your inbox besides going to Redmond?
I'm currently also looking into the release of .NET 2.2 to make sure we have no regressions. Yes. We also we also plan for some new performance related features. We also work on tired cheating currently. Yeah. So there is a lot of things going on with performance.
Cool.
Yeah, exciting times. And I love that it's across operating systems too.
Yeah.
So, it feels like this System.Memory class is about being able to respect the variations in operating systems while using .NET stuff.
Yes.
That's really powerful.
And I love the fact that it's open source. I've been working at Microsoft for almost a year, and so far I haven't touched anything which wasn't open source.
That's
great.
Really neat.
Yeah.
You live in GitHub for your job.
So I'm not even using VPN.
Wow.
Okay.
It's just open source. Yeah. It's SSL is enough.
Well, Adam, thanks very much for being with us today. It was a pleasure talking to you.
Thank you very much for having me.
All right. And we'll see you next time on .NET Rocks. .NET Rocks is brought to you by Franklin's Net and produced by Plop Studios, a full-service audio, video, and post-production facility located physically in New London, Connecticut, and of course in the cloud. Online at pwop.com. Visit our website at dotnetrocks.com for RSS feeds, downloads, mobile apps, comments, and access to the full archives going back to show number 1, recorded in September 2002. And make sure you check out our sponsors. They keep us in business. Now go write some code. See you next time. Got transmitter banned by the FCC. Yes, I'm a